Astronomers now fear that 3I/Atlas, the mysterious interstellar visitor streaking through our solar system, may be tearing itself apart. New images reveal distortions in its tail, sudden dips in brightness, and a chemical imbalance that defies everything we know about comets. NASA teams and independent observers are scrambling to explain what they're seeing, while the James Webb Space Telescope has just added another layer of confusion. During the recent lunar eclipse, 3I/Atlas even glowed an eerie green, as if broadcasting its otherworldly chemistry into the night sky. For some researchers, this isn't just another interstellar comet, it's behaving like nothing we've ever seen before. And the deeper scientists look, the more disturbing the puzzle becomes. Because the latest data suggests something impossible. 3I/Atlas is no ordinary comet. It is only the third confirmed interstellar object ever detected, after Oumuamua in 2017 and 2I/Borisov in 2019. That places it in an elite and troubling category, travelers that did not form in our solar system, but in the chaos of another star system far away. Unlike the countless comets orbiting our sun, 3I/Atlas is on a hyperbolic trajectory. In other words, it isn't bound to our star's gravity. It came from deep space, will slice once through the solar system, and then vanish back into the void forever. That fact alone makes every observation a once-in-a-civilization event. Oumuamua shocked astronomers by accelerating mysteriously without outgassing. Borisov looked more like a conventional comet, though it carried alien chemistry. But 3I/Atlas? Already it is proving stranger still, its light, color, and structure refusing to match anything we thought we understood. And that's why, when the first irregularities appeared, scientists knew this was not just another cometary story. When astronomers traced 3I/Atlas back through archival sky surveys, they uncovered pre-covery images, faint snapshots of the object taken before anyone even realized it existed, and hidden in that early data were warning signs. Its brightness wasn't stable. Instead of following the smooth, predictable curve of a comet warming under sunlight, 3I/Atlas showed sudden dips and erratic surges, as if parts of its structure were already unstable. Then came the tail. Most comets form a tail gradually, streaming dust and gas away as they near the sun. But 3I/Atlas sprouted a sharp anti-solar tail far earlier than expected, pointing directly away from the sun like a defiant plume. It was a signal that volatile materials inside were venting in unusual ways. Even stranger was its color evolution. At first, 3I/Atlas appeared distinctly red, an indicator of organic-rich dust. But as weeks passed, that red shifted closer to solar hues, washing out into something almost neutral. Astronomers were left asking, was its surface material being stripped away, exposing something new beneath? Each irregularity chipped at the idea that this was a normal comet. 3I/Atlas was broadcasting warnings, subtle at first, but growing louder with every observation. And soon, those warnings would escalate into outright impossibilities. The next wave of data made astronomers uneasy. The light curve of 3I/Atlas, the record of how its brightness rises and falls, wasn't behaving normally. Instead of a smooth climb as it neared the sun, its light flickered with irregular dips, suggesting that large fragments or clouds of dust might be temporarily blocking the view. Then, telescopes noticed distortions in its tail. Instead of flowing in one clean direction, like the elegant plume of a typical comet, the dust stream of 3I/Atlas twisted and warped. On some nights, it even appeared asymmetric, with gas and dust spraying unevenly from different regions of its coma. That's often the fingerprint of a comet undergoing structural failure. Astronomers have seen this before. Comet Shoemaker-Levy 9 famously broke into more than 20 fragments before colliding with Jupiter in 1994. Comet Ison disintegrated spectacularly in 2013 as it swung too close to the sun. Both cases left a familiar signature: uneven outgassing, tail distortions, and unpredictable brightness shifts. At first glance, 3I/Atlas seems to be walking that same path, a fragile ice body fracturing under the stress of interstellar travel and solar heating. But there's a problem. Its distance from the sun, its chemical makeup, and the sheer scale of the anomalies don't match the script. If 3I/Atlas really is breaking apart, it's doing so under conditions that should be impossible. And that raises the most unsettling question yet. What exactly is tearing this object apart? If the breakup clues weren't troubling enough, the James Webb Space Telescope delivered a discovery that stunned comet scientists. Using its infrared spectrographs, Webb detected that the coma of 3I/Atlas, the gas cloud surrounding its nucleus, was dominated by carbon dioxide. The ratio was extraordinary, 8 parts CO2 for every 1 part. Water. In our solar system, comets are almost always water-rich, with CO2 playing only a supporting role. That's because water ice is abundant in the outer reaches of the sun's disk, while carbon dioxide usually makes up only a fraction of a comet's mass. To find a body so heavily skewed towards CO2 is like encountering an ocean that's mostly carbonated gas. It simply doesn't fit our models. This imbalance raised uncomfortable questions. Did 3I/Atlas form in an alien environment where water was scarce? Or is something else happening inside, processes that strip water away and leave only volatile carbon dioxide behind? One astronomer summed it up bluntly: that imbalance shouldn't even exist here, and yet it does. Which leaves us with a deeper mystery. If 3I/Atlas carries the chemical fingerprint of a world unlike our own, what does that say about its true origin, and why is it falling apart so quickly? As if the chemistry weren't strange enough, ground-based telescopes and spectrographs picked up another shock: signs of water activity where it shouldn't exist. At a distance of 3.5 astronomical units, more than 3 times farther than Earth's orbit, 3I/Atlas showed OH emission, the telltale fingerprint of water molecules being broken apart by sunlight. Normally, comets only release water vapor once they're closer to the sun, where heat is strong enough to melt surface ice. At 3.5 astronomical units, water should remain locked and dormant. So why was 3I/Atlas venting water this early, this far out? Some scientists suggested it might be unusually hyperactive, with hidden reservoirs erupting from its interior. Others proposed that an unknown energy source could be driving sublimation in ways never seen before. One researcher admitted, it's either hyperactive or something else is driving it. Either explanation is unsettling, and both lead to the same conclusion. 3I/Atlas is not playing by the rules of our solar system's comets. The puzzle deepened when astronomers analyzed the polarization of light scattering off 3I/Atlas's coma. Polarization tells scientists about the size, composition, and texture of the dust surrounding a comet, about what this object really is. And so the question lingers: if 3I/Atlas isn't splitting apart, what is it doing? Whatever the answer, astronomers are running out of time. On October 3rd, 2025, 3I/Atlas will pass near Mars, offering a front row seat to orbiters and rovers already stationed there. Just weeks later, on October 29th, it will reach its closest point to the Sun, its perihelion, where the heat and stress could push it past the breaking point. Will it fragment into a cascade of shards, like Comet Shoemaker-Levy 9? Will it flare into a sudden burst of brightness, releasing all its hidden reserves? Or will it fade into nothing, dissolving silently into the solar wind? No one can say for sure, but the stakes are enormous. Every major telescope, from the Hubble successor to ground-based observatories across Earth, is preparing to track its every move. As one astronomer put it, every telescope on Earth will be watching. In the end, we're left with an unsettling truth. If 3I/Atlas is tearing itself apart, we are witnessing a rare and historic event: the slow death of an interstellar wanderer. But if it isn't, then something stranger is happening. Something that challenges the very categories we use to classify objects in the sky. An alien chemistry, an impossible breakup, a visitor behaving unlike anything we've ever seen. And the question remains, what exactly is 3I/Atlas? Whatever the answer, its story is far from over. And in the coming weeks, the skies may deliver revelations no one is prepared for. Because whatever happens to 3I/Atlas next, fragmentation, flare, or silence, it will change how we see visitors from the stars. Don't miss what comes next.